It's hard to believe, but deep beneath the Pacific, life is thriving in conditions we once thought impossible. Could this be a window into life beyond Earth?
Through this volcanic cycle, we're learning things. A mile of water sitting on top of them, which is, dampens it, but they also don't have as much gases.
And if so, what does that mean for us? 1,000 meters below the restless surface of the Northeast Pacific, hidden by crushing pressure and perpetual night, the ocean floor stirs. Off British Columbia's tranquil shores and Oregon's rugged coast, a giant waits. This is Axial Seamount, a colossal undersea volcano swelling with magma and mystery. From above, life looks normal. Ferries crisscross islands, children play on beaches, eagles glide in the wind. But below, seismic sensors tell another story. Something is growing on axial slopes. Something no one expected, and some scientists whisper, might not even be entirely of this world. Chapter 1. Alien Volcano Rising. What happens when a mountain that never sleeps starts to swell faster than ever before? Deep below the red Pacific Ocean floor, red Axial Seamount is rising like a hidden giant. Scientists monitoring the red Canada undersea volcano and the red Juan de Fuca Ridge have recorded seismic activity and swelling that surpasses every eruption in its recent history. Since early 2025, the seafloor has been steadily inflating, its summit lifting higher with each passing week. This process, known as red volcanic inflation, occurs when magma builds beneath the crust, creating massive pressure. Unlike volcanoes on land, however, this growth is invisible to the naked eye, hidden under kilometers of water, detected only by instruments. What makes red Axial Seamount eruption prediction so important is its location. Sitting just off the coasts of red British Columbia and red Oregon, this red submarine volcano lies along one of the most active fault systems in the world. The red Juan de Fuca tectonic plate pushes relentlessly beneath the red North American plate, fueling not just axial, but a chain of volcanic systems stretching along the red Pacific Ring of Fire. The most alarming part? Inflation at axial has already surpassed levels seen before its last 3 eruptions, in 1998, 2011, and 2015. Yet no eruption has come. Instead, the ground continues to rise, and hundreds of tiny quakes tremble through the seamount daily. Scientists now warn this could be a precursor to the next red mega eruption undersea, possibly the most documented event in submarine volcanic history. And here's the twist. This red Canadian underwater volcano is not just about lava and earthquakes, it's also about biology. The swelling mountain is surrounded by hydrothermal vents where unusual life thrives. If axial erupts again, it won't only reshape the seafloor, it could reset entire ecosystems, erase existing vent fields, and give birth to new ones. Could the red Axial Seamount eruption 2025 reveal more than just magma? Could it expose life forms that challenge our very definition of what belongs on Earth and what doesn't? Chapter 2. Life where none should exist. How can life flourish where sunlight never shines and boiling acid spews from the Earth? On the slopes of the red Axial Seamount, far below the red Pacific Ocean surface, lies a world that defies everything we thought we knew about biology. Around hydrothermal vents, known as red-black smokers, hot water infused with toxic chemicals erupts from the crust. Temperatures soar above 350 degrees Celsius. Pressures crush beyond imagination, and sunlight is absent. Yet in this so-called impossible zone, life not only survives, it thrives. The red hydrothermal vent ecosystems around the red Canadian undersea volcano teem with organisms adapted to extremes. Towering chimneys formed from dissolved minerals become the backdrop for bizarre creatures. Tube worms with scarlet plumes filter chemical energy, while ghostly shrimp swarm in boiling plumes. Pale crabs scuttle across vent walls, blind and yet perfectly adapted.
Even octopuses have been seen curling through these fleeting oases, exploring as if guided by unseen instincts. But the true marvel lies at the microscopic level. Scientists studying microbial mats around red axial seamount vents have discovered genetic signatures unlike anything catalogued on land. Their DNA reveals red unusual enzymes and red rare proteins that allow survival in toxic, oxygen-deprived waters. Some strains metabolize hydrogen sulfide and methane with efficiency never seen before. These adaptations echo the conditions hypothesized for life on red Europa's ocean or beneath the icy crust of red Enceladus, making Axial a natural laboratory for red astrobiology research. Why does this matter? Because every discovery at Axial pushes the boundary of what life on Earth can mean. Some microbes show mirror image amino acids, a chemistry that seems almost unearthly. Others hint at ancient evolutionary relics, possibly survivors from the earliest days of life itself, when Earth was young and hostile. If the red axial seamount eruption 2025 resets these vent fields, entire ecosystems could vanish overnight. But with destruction comes creation. New vents would form, and with them perhaps even stranger life. Could the next eruption reveal organisms with even more alien characteristics? Could the red Pacific underwater volcano ecosystems already be holding the closest analogues to extraterrestrial biology we'll ever find? Until we drill Europa's ice. If you're stunned that life can thrive in conditions this extreme, imagine what else might be waiting out there. Don't miss what's coming. Subscribe now and stay with us as we dive deeper into the secrets this undersea volcano is hiding. Chapter 3. Seismic Countdown. What if the ticking clock beneath the Pacific isn't counting down to lava, but to discovery? Beneath the red Pacific Ocean floor, the red axial seamount continues its quiet inflation. Since the beginning of red 2025 volcanic monitoring, instruments have recorded the seafloor rising steadily, centimeter by centimeter, but with consequences measured in global importance. Every tremor matters. Scientists note hundreds of red micro-earthquakes at axial seamount every single day, quakes too faint for humans to feel, but crucial for reading the volcano's restless state. This activity signals magma pressing upward, straining the crust. In 2011 and 2015, similar signals preceded eruptions. Yet now, the inflation exceeds all past records without any eruption. The red axial seamount eruption prediction 2025 is filled with uncertainty. Has the magma chamber changed shape? Is it storing more pressure than before? Or could Axial be entering a longer eruptive cycle, where the eventual release will dwarf the last events? What alarms researchers is the unpredictability. Even with state-of-the-art red seafloor observatories and red volcanic monitoring systems Canada, forecasting remains guesswork. Predictions range from days away to years away. In Vancouver, Seattle, and Portland, the public is reassured that no tsunami or major surface danger is expected. But for scientists, this is about more than safety. It's about knowledge. Each tremor, each inflationary pulse is a chance to glimpse Earth's mechanics in real time.
Could the next rupture not just release lava, but also unlock life forms from vents sealed for centuries? Could the cycle of red volcanic inflation and eruption actually be a mechanism that seeds new ecosystems across the ocean floor? The countdown ticks. But is it to disaster or discovery?
Chapter 4. Alien Chemistry in the Deep. What if the first signs of extraterrestrial life are not found in space, but in our own oceans? At the red Axial Seamount vent fields, scientists are uncovering biochemistry that challenges every rulebook. DNA from microbes around these red hydrothermal vents reveals unusual amino acids, mirror image proteins, and metabolic pathways never seen in typical surface organisms. These microbes thrive in toxic soups of hydrogen sulfide, methane, and iron. Their enzymes, known as red extremophile enzymes, withstand conditions lethal to most life. This matters because astrobiologists use Earth as a guide for searching beyond. The chemistry at Axial resembles what models predict for potential life beneath the ice of red Europa's ocean, or in the methane-rich seas of red Titan, or within the hidden hydrothermal plumes of red Enceladus. Studying these microbes is not only about biology, it's about preparing to recognize alien life if and when we find it. For example, some strains metabolize entirely without oxygen, relying on red chemosynthesis, a process where energy comes from chemicals rather than sunlight. This is the same process believed possible under icy moons. Others produce proteins stable at both extreme heat and crushing pressure. Such resilience shows how adaptable life can be, and why it may not be unique to Earth. Could these microbes be ancient holdovers from Earth's first life forms? Or have they evolved independently in the dark, creating almost a parallel biosphere? If so, is it fair to call them Earth life at all? Or are they the closest thing to alien organisms we've already discovered? The Red Axial Seamount Life Discovery 2025 forces us to ask, if life can thrive in these abyssal extremes, isn't it almost inevitable that similar life exists elsewhere in the cosmos?
Chapter 5. Watching the Unseeable. If we can't see the volcano, how do we know its every move? Unlike land volcanoes, the red Axial Seamount volcano is buried under a kilometer of water, yet it is one of the most closely monitored volcanoes on Earth. Networks of red fiber optic cables on the seafloor send real-time data to Vancouver, Seattle, and Portland. Autonomous underwater vehicles map its slopes, tracking fissures and vent activity. Satellites detect subtle gravity changes from space. Sensors can measure the tiniest details, vent water changing by half a degree, cracks widening by millimeters, earthquakes smaller than a whisper. Together, this paints a real-time portrait of the seafloor shifting, rising, and trembling. In April 2025, instruments showed inflation beyond all past levels, yet still, the volcano stayed silent. This defiance of past patterns unsettles researchers. What if Axial is rewriting its own rules? Could this mean larger eruptions, or longer cycles between them? Or is our monitoring finally sensitive enough to reveal complexities we never noticed before? This global effort is not only about predicting eruptions, it's also about understanding Earth's hidden systems. The Red Canada Submarine Volcanic Monitoring Program has become a model for international cooperation, linking data from the US, Canada, and beyond. Every tremor logged at Axial is shared, creating a global science laboratory. But here's the chilling question. If with all this technology we still cannot predict the eruption precisely, what does that say about our deafening to predict other seismic events, like the Red Cascadia Subduction Zone Megathrust earthquake? Chapter 6. Genetic Shadows. What secrets lie hidden in DNA sequences no one has ever seen before? In labs across Canada and the US, Samples from the red axial seamount microbes are rewriting biology textbooks. When scientists run their DNA through sequences, they find red, unknown genetic sequences, codes not recorded in any database. Some proteins twist in mirror image formations, known as red chiral anomalies in biology. Others produce enzymes so resilient they may become industrial tools for biotechnology. One astonishing discovery: certain microbes appear to metabolize using pathways almost never seen in surface organisms. Instead of oxygen, they rely on sulfur and methane, turning toxic chemicals into energy. This process may resemble the earliest life forms on Earth, billions of years ago. Astrobiologists seize on this. If life once began in environments like these, could it also arise independently on distant worlds? Could the genetic shadows in Axial's microbes hint at a universal pattern? Life shaped by chemistry, not sunlight. Some researchers speculate, are these organisms relics from before Earth's oxygen revolution? Survivors of an ancient biosphere? If so, they may represent an almost alien branch of life still persisting here, under our oceans. The red axial seamount DNA discovery could even help design future Mars and Europa missions. If probes detect similar chemistry elsewhere, these microbes will be the benchmark for recognizing alien life. So we must ask, if the ocean floor is already hosting life that feels alien, does that mean Earth has always been a two-world planet? Surface and abyss, coexisting but separate. Chapter 7: Cycles of Destruction and Renewal. What if every eruption is not an ending, but the beginning of something entirely new? The red axial seamount eruptions of 1998, 2011, and 2015 showed one undeniable truth. Every blast rewrites the ocean floor. Old vents collapse, new chimneys rise, ecosystems vanish, and new ones bloom in days. This cycle of destruction and renewal accelerates evolution. Microbes adapt to new chemistry. Worms colonize fresh vents. Genetic drift speeds up, creating entirely new strains within years. Scientists call Axial an evolutionary hotspot, a place where life evolves at a pace rarely seen. It's also a reminder of resilience. Within days of an eruption, life surges back. Within months, ecosystems thrive again. Within years, entirely new microbial lineages emerge. This resilience makes the red submarine volcanic ecosystems Canada one of the best models for how life survives chaos. But what does this mean for us? If life here thrives on destruction, could alien life follow the same rule? Could entire biospheres exist in cycles of catastrophe, constantly reborn? The red axial seamount eruption life cycle suggests that destruction isn't always an end. It can be a spark. Perhaps on Europa or Enceladus, life too is written in cycles of catastrophe and rebirth. Mirror of creation. Are we looking at Earth's past or the universe's future? For many scientists, the red axial seamount ecosystems are time machines. They mirror what Earth may have looked like 3.5 billion years ago. An ocean planet teeming with microbial life feeding on chemistry alone. But they are also windows into possible futures. If humanity finds life elsewhere, it will likely look like this. Microbial mats clinging to vents, organisms built on sulfur, methane, and heat. The red hydrothermal vent life Canada Pacific is the closest analogue to what astrobiologists hope to find on Europa or Enceladus. This duality, past and future, makes Axial more than just a volcano. It is a living laboratory, showing us both where we came from and where we might find others like us. Could it be that Earth's deep oceans hold the blueprint of life across the universe? And if so, are we ready to recognize it when we see it? Chapter 9. The Next Blast. If this volcano erupts tomorrow, what secrets will spill out with its fire? The inflation continues. The pressure builds. The red Axial Seamount eruption forecast 2025 grows more urgent. Scientists wait for lava, but what they're truly waiting for is knowledge. The eruption, when it comes, will destroy some vents but create others. It will bury ecosystems but reveal new ones. And in the aftermath, researchers will dive again, searching for new microbes, new chemistry, new insights into life itself. For most people, the eruption will go unnoticed. No cities will fall, no tsunamis will strike. But for science, it will be a revolution. Could the eruption of Red Canada's undersea volcano finally deliver proof of biochemical processes that exist beyond our planet? Could a plume of microbes from Axial rewrite what we thought life could be? The countdown is on. But what explodes here isn't just magma. It's knowledge. If you want to be among the first to see what scientists uncover when the next blast finally hits, make sure you subscribe, hit the notification bell, and share this video. Because the moment Axial erupts, the world may learn something that changes our view of life forever.